Welcome to CO451 Networking. This is week 11, and this week we're looking at the transport layer. So this week's objective is to compare the operations of transport layer protocols in supporting end-to-end communication. We will look at the transportation of data. We're given a TCP Overview, UDP Overview, port numbers, TCP Communication Process, reliability and flow control, UDP Communication. Transportation of data. The role of the transport layer. The transport layer is responsible for logical communications between applications running on different hosts. The link between the application layer and the lower layers that are responsible for network transmission. Transport layer responsibilities. The transport layer has the following responsibilities: tracking individual conversations, segmenting data and reassembling segments, adds header information, identify, separate and manage multiple conversations, uses segmentation and multiplexing to enable different communication conversations to be interleaved on the same network. Transport layer protocols. IP does not specify how the delivery or transportation of the packets takes place. Transport layer protocols specify how to transfer messages between hosts and are responsible for managing reliability requirements of a conversation. The transport layer includes the TCP and UDP protocols. Transmission Control Protocol. TCP provides reliability and flow control. TCP basic operations are: number and track data segments transmitted to a specific host from a specific application, acknowledge received data, retransmit any unacknowledged data after a certain amount of time, sequence data that might arrive in the wrong order, send data at an efficient rate that is acceptable by the receiver. User Datagram Protocol, UDP. UDP provides the basic functions for delivering datagrams between the appropriate applications with very little overhead and data checking. UDP is a connectionless protocol. UDP is known as Best Effort Delivery Protocol because there is no acknowledgement that the data is received at the destination. The right transport layer protocol for the right application. UDP is also used by request and reply applications, where data is minimal, and retransmission can be done quickly. If it is important that all data arrives and that it can be processed in a proper sequence, TCP is used as the transport protocol. TCP Overview. TCP features. Establishes a session. TCP is a connection-oriented protocol that negotiates and establishes a permanent connection or session between source and destination devices prior to forwarding any traffic. Ensures reliable delivery. For many reasons, it is possible for a segment to become corrupted or lost completely, as it is transmitted over the network. TCP ensures that each segment that is sent by the source arrives at the destination. Provides same order delivery. Because networks may provide multiple routes that can have different transmission rates, data can arrive in the wrong order. Supports flow control. Network hosts have limited resources, i.e. memory and processing power. When TCP is aware that these resources are overtaxed, it can request that the sending application reduce the rate of data flow. TCP header. TCP is a stateful protocol, which means it keeps track of the state of the communication session. TCP records which information it has sent and which information has been acknowledged. TCP header fields. Source port. A 16-bit field used to identify the source application by port number. Destination port. A 16-bit field used to identify the destination application, again by port number. Sequence number, a 32-bit field used for data reassembly purposes. Acknowledgement number, a 32-bit field used to indicate that data has been received and the next byte expected from the source. Header length, 4-bit field known as data offset that indicates the length of the TCP segment header. Reserved, a 6-bit field that is reserved for future use. Control bits, a 6-bit field used that includes bit codes or flags which indicate the purpose and function of the TCP segment. Window size, a 16-bit field used to indicate the number of bytes that can be accepted at any one time. Checksum, a 16-bit field used for error checking of the segment header and data. Urgent, a 16-bit field used to indicate if the contained data is urgent. Applications that use TCP. TCP handles all tasks associated with dividing the data stream into segments, providing reliability, controlling data flow, and reordering segments. UDP Overview. UDP features. UDP features include the following. Data is reconstructed in the order that it is received. Any segments that are lost are not resent. There is no session establishment. The sending is not informed about resource availability. UDP header. UDP header is far simpler than TCP header because it only has 4 fields and requires 8 bytes, i.e. 64 bits. UDP header fields. The table below identifies and describes the 4 fields in the UDP header. Source port, a 16-bit field used to identify the source application by port number. Destination port, a 16-bit field used to identify the destination application, again by port number. Length, a 16-bit field that indicates the length of the UDP datagram header. Checksum, a 16-bit field used for error checking of the datagram header and data. Applications that use UDP. Live video and multimedia applications. These applications can tolerate some data loss, but require little or no delay. Examples include VoIP and live streaming video. Simple request and reply applications. Applications with simple transactions where a host sends a request and may or may not receive a reply. Examples include DNS and DHCP. Applications that handle reliability themselves. Unidirectional communications where flow control, error detection, acknowledgements and error recovery is not required, or can be handled by the application. Examples include SNMP and TFTP. Port numbers. Multiple separate communications. TCP and UDP transport layer protocols use port numbers to manage multiple simultaneous conversations. The source port number is associated with the originating application on the local host, whereas the destination port number is associated with the destination application on the remote host. Socket pairs. The source and destination ports are placed within the segment. The segments are then encapsulated with an IP packet. The combination of the source IP address and the source port number, or the destination IP address and the destination port number, is known as a socket. Sockets enable multiple processes running on a client to distinguish themselves from each other, and multiple connections to a server process to be distinguished from each other. Port number groups. The well-known ports 0 to 1023. These port numbers are reserved for common or popular services and applications such as web browsers, email clients, and remote access clients. Defined, well-known ports for common server applications enables clients to easily identify the associated service required. Registered ports 1024 to 49151. These port numbers are assigned by IANA to a requesting entity to use with specific processes or applications. These processes are primarily individual applications that a user has chosen to install, rather than common applications that will receive a well-known port number. For example, Cisco has registered port 1812 for its radius server authentication process. Private and/or dynamic ports 49,152 to 65,535. These ports are also known as ephemeral ports. The client's OS usually assigns port numbers dynamically when a connection to a service is initiated. The dynamic port is then used to identify the client application during communication. Port number groups. Port 20, TCP, File Transfer Protocol, FTP. 21, TCP, File Transfer Protocol, FTP, the control. Port 22, TCP, Secure Shell, SSH. 23, TCP, Telnet. 25, TCP, Simple Mail Transfer Protocol, SMTP. 53, UDP TCP, Domain Name Services, DNS. 67, UDP, Dynamic Host Configuration Protocol, DHCP, Server. 68, UDP, Dynamic Host Configuration Protocol, Client. 69, UDP, Trivial File Transfer Protocol, FTP. Port 80, TCP, Hypertext Transfer Protocol, HTTP. 110, TCP, Post Office Protocol, version 3, POP3. 143, TCP, Internet Message Access Protocol, IMAP. 161, UDP, Simple Network Management Protocol, SNMP. 443, Hypertext Transfer Protocol, Secure, TCP. The netstack command. Unexplained TCP connections compose a major security threat. Netstat is an important tool for verifying connections. TCP Communication Process. TCP server processes. Each application process running on a server is configured to use a port number. An individual server cannot have two services assigned to the same port number within the same transport layer services. An active server application assigned to a specific port is considered open, which means that a transport layer accepts and processes segments addressed to that port. Any incoming client request addressed to the correct socket is accepted, and the data is passed to the server application. TCP connection establishment. Step 1. The initiating client requests a client-to-server communication session with the server. Step 2. The server acknowledges the client-to-server communication session and requests a server-to-client communication session. The initiating client, in Step 3, acknowledges the server-to-client communication session. Session termination. Step 1. When the client has no more data to send in the stream, it sends a segment with a FIN flag set. Step 2. The server sends an acknowledgement, ACK, to acknowledge the receipt of the FIN to terminate the session from the client to server. Step 3. The server sends a FIN to the client to terminate the server to client session. Step 4. The client responds to an acknowledgement, ACK, to acknowledge the FIN from the server. TCP three-way handshake analysis. Functions of the three-way handshake. It establishes that the destination device is present on the network. It verifies that the destination device has an active service and is accepting requests on the destination port number that the initiating client intends to use. It informs the destination device that the source client intends to establish a communication session on that port number. After the communication is completed, the sessions are closed and the connection is terminated. The connection and session mechanisms enable TCP reliability function. TCP three-way handshake analysis. The 6 control bit flags are as follows. URG, urgent pointer field significant. ACK, acknowledgement flag, used in connection establishment and session termination. BSH, push function. RST, reset the connection when an error or timeout occurs. SYN, synchronized sequence numbers, used in connection establishment. FIN, no more data from sender, and used in session termination. Reliability and flow control. TCP reliability guaranteed and ordered delivery. TCP can also help maintain the flow of packets so that devices do not become overloaded. There may be times when TCP segments do not arrive at their destination or arrive out of order. All the data must be received, and the data in these segments must be reassembled into the original order. Sequence numbers are assigned in the header of each packet to achieve this goal. TCP reliability, data loss and retransmission. No matter how well designed a network is, data loss occasionally occurs. TCP provides methods of managing these segment losses. Among these is a mechanism to retransmit segments for unacknowledged data. TCP reliability, data loss and retransmission. Most operating systems today typically employ an optional TCP feature called selective acknowledgement, SAC. Negotiated during the three-way handshake. If both hosts support SAC, the receiver can explicitly acknowledge which segments bytes are received during any discontinuous segments. TCP flow control, window size and acknowledgements. TCP also provides mechanisms for flow control as follows. Flow control is the amount of data that the destination can receive and process reliably. Flow control helps maintain the reliability of TCP transmission by adjusting the rate of data flow between source and destination at a given session. TCP flow control, maximum segment size. Maximum segment size, MSS, is the maximum amount of data that the destination device can receive. A common MSS is 1,460 bytes when using IP version 4. A host determines the value of its MSS field by subtracting the IP and TCP headers from the Ethernet maximum transmission unit, the MTU, which is 1500 bytes by default. 1500 minus 60, 20 bytes for the IPv4 header and 20 bytes for the TCP header, leaves 1460 bytes. TCP flow control, congestion avoidance. When congestion occurs on a network, it results in packets being discarded by the overloaded router. To avoid and control congestion, TCP employs several congestion handling mechanisms, timers and algorithms. UDP communication. UDP low overhead versus reliability. UDP does not establish a connection. UDP provides low overhead data transport because it has a small datagram header and no network management traffic. UDP datagram reassembly. UDP does not track sequence numbers the way TCP does. UDP has no way to reorder the datagrams into their transmission order. UDP simply reassembles the data in the order that it was received and forwards it to the application. UDP server processes and requests. UDP-based server applications are assigned well-known or registered port numbers. UDP receives a datagram destined for one of these ports. It forwards the application data to the appropriate application based on its port number. UDP client processes. The UDP client process dynamically selects a port number from a range of port numbers and uses this as the source port for the conversation. The destination port is usually the well-known or registered port number assigned to the server process. After a client has selected the source and destination ports, the same pair of ports are used in the header of all datagrams in the transaction. Module practice and quiz. The packet tracer exercise TCP and UDP communications asks you to generate network traffic in simulation mode and examine the functionality of the TCP and UDP protocols. What did we learn this week? The transport layer is the link between the application layer and the lower layers that are responsible for network transmission. The transport layer includes TCP and UDP. TCP establishes sessions, ensures reliability, provides same order delivery, and supports flow control. UDP is a simple protocol that provides the basic transport layer functions. UDP reconstructs data in the order it is received. Lost segments are not resent, no session establishment, and UDP does not inform the sender of resource availability. The TCP and UDP transport layer protocols use port numbers to manage multiple simultaneous conversations. Each application process running on a server is configured to use a port number. The port number is either automatically assigned or configured manually by a system administrator. For the original message to be understood by the recipient, all the data must be received and the data in these segments must be reassembled into the original order. Sequence numbers are assigned in the header of each packet. Flow control helps maintain the reliability of TCP transmission by adjusting the rate of data flow between source and destination. A source might be transmitting 1460 bytes of data within each TCP segment. This is the typical MSS that the destination device can receive. The process of the destination sending acknowledgements as it processes bytes received and the continual adjustment of the source's send window is known as sliding windows. To avoid and control congestion, TCP employs several congestion handling mechanisms.